All right, for the first half of the double today, what you'll be doing is solving simultaneous linear and quadratic equations. Sounds complicated, really, it's not that bad. So what we can do is use a similar method to linear functions. We could do that graphically, so that is draw both graphs, but really you'd only do that in CAS. And I wouldn't graph them in CAS and solve them simultaneously. I would do it algebraically on CAS. And I'll show you both of those methods. So depending on where or if the straight line intersects the parabola, we can have basically three scenarios, 2, 1, or 0 solutions. How does that work? Well, what can happen is that we get this situation here, 2 points of intersection. So the linear function goes through and cuts the parabola twice, and it will only ever be a maximum of twice. You get this thing where the parabola runs along, nicks it, and then keeps going. So that's one intersection. It's called the tangent, that. Or the linear function could actually just miss the parabola altogether. So you get no point of intersection. So let's try one out. So we can find the points of intersection between this function here and this function here. So this is the parabola, this is the linear. So what I do is I let them equal each other. So I'm going to go negative 2x plus 4 equals x squared take 8x plus 12. All right, so now we want to get a solvable quadratic function and see whether it's got solutions. It might have 0 solutions, 1 solution, or 2 solutions. Let's see what happens here. I'm going to go 0 equals x squared. I'm going to add 2x to both sides, which gives me negative 6x, and I'm going to subtract 4 from both sides, which means that I've got positive 8. All right, let's see if we can factorize this thing, and it's going to be 2 and 4 x, and they're both going to be negative. 0 equals x take 2, x take 4. Okay, so it's obvious that there's two solutions here. So first solution is going to be when x is equal to 2, and the other solution is going to be x is equal to 4. Now, how do we get the y? Well, we just choose one of these to sub it into. I'm going to bang it into the linear. So that's going to be negative 2 times 2, which is negative 4. That's going to be at 0. And 4 in here is going to be negative 8. Negative 8 plus 4 is negative 4. So this one here is 2, 0. This one here is 4, negative 4. All right, let's see how or what that looks like graphically. So here's my calc. So what I'm going to do is just go to graph and table, graph the linear, y equals 2x plus 4. Oops. There's that. And the quadratic x squared takes 6x plus 8. And what I could see is there's an intersection there, and obviously another intersection at negative 4. Ooh, see, that's interesting. That's really silly of me there. So what I've done is graphed the third function that I've made with the addition of the second function. So this is a good lesson in, well, what should have happened didn't happen there. So obviously this is the first function here, and what I should have done obviously is graph that function, not the third function that I made. So it's good to note that, yeah, that's obviously an error. So there's our first intersection there. And if we scroll down, voila, 4, neg 4 there. Now what you can do is go analysis, gsolve, and intersection, and that will pull up the two intersection points. Now I highly recommend you do not use this approach. If the intersection points are irrational, your calculator approximates them. So if you actually want to do this on the calc, the best way to do it is to just run a solve. And what you do is you type in what you want to solve at 2x plus 4 equals x squared take 8x plus 12 for x, and there you got your 2x values as well. Okay, so that's a much better way of doing it than sub those values in. The final way I want to show you is just with the template. So y equals negative 2x plus 4. This is probably the best method. Y equals x squared. I want to type in the right function this time. Take 8x plus 12, x comma y, and there's our two solution sets. Okay, so let's have a look at this next question here. So we've got a linear and a quadratic, and we're just interested in how many points of intersection. So let's do it. 2x take 5 equals 2x squared plus 5x plus 6. So we're going to go 0 equals 2x squared plus 3x, and I'm going to add 5 to both sides, which is 11. Right, how many solutions? Well, I could attempt to factorize, blah, blah, blah. That's not going to work. I just want to know how many solutions I've got. So the best thing to do is actually run the discriminant on that. Okay, so what we'll do is we'll have a look at the discriminant. So discriminant is equal to b squared take 4ac. And that tells you the number of solutions that comes out of a quadratic function, or can come out of a quadratic function. So let's go. Discriminant is b, which is 9. Take away 4 times 2 times 11 equals 9. Take away 4 11s are 44, 88. Negative 79. So discriminant is less than 0, therefore no solutions. So what I'm anticipating here obviously is we've got a parabola. Don't really know what it looks like, but something like that maybe. The linear goes through -5, positive gradient runs along there, and obviously never intersects it. So it does not have any solutions, therefore no solutions, and thus no intersection. Okay, let's have a look. All right, so what we've introduced here is a parameter, and we've got equations y equals mx plus 5 and y equals x squared take 8x plus 14. For what values of m will there be one intersection? Okay, so let's just sort of see what happens if we follow the same approach as last time. Mx plus 5 equals x squared take 8x plus 14. Now I'm going to go x squared take 8x take mx plus 9 after subtracting 5 from both sides. Okay, so what I'm going to do for this is run the discriminant. Okay, and what I'm going to do is let the discriminant equal 0, because one intersection means discriminant equals 0. Remember, discriminant is greater than 0. We've got 2 equal to 0, 1, discriminant less than 0, which was the last example. We've got no solutions. So that's the plan of attack here. So to do that, I'm just going to rewrite the coefficient. I'm going to pull negative 8 take m x. Did I do that right? Negative 8 plus m, negative 8x, negative mx plus 9. Okay, so here's what we're going to do. Discriminant is b squared take 4ac. Discriminant is b, which is negative 8 plus m, all squared. Take away 4 times 1 times 9. Discriminant equals, we're squaring a negative here, and we're going to do a perfect square expansion, which is 64 plus 16m plus m squared. Take away 36. All right, let's put that into a bit more of a familiar setup. M squared plus 16m, 4 to 40, 24, 28, I think, plus 28, 64, 54, 44, 34, 28. Yeah, I think I got that right. Okay, so what we've got here is we've created a discriminant versus M, and actually we can graph that. And I know Mr. Miller is, the other Mr. Miller is going to show you how to do this for the previous exercise. This is a really good thing to do. Let's go M, 14 and 2. Yep, that'll do. Discriminant is equal to M plus 14, M plus 2. Okay, so it's going to be -2, -14. Here's our graph. This is the discriminant Vm. Right, now what does this tell us? We want one intersection only. Okay, so that is when M plus 14, M plus 2 is equal to 0. Well, it's easy. M equals -14, M equals -2. All right. Now, always a second part to this. For what values of M will there be at least one intersection? So that's when M plus 14, M plus 2 is greater than or equal to 0. Now again, to solve a quadratic inequality, you must look at the graph. And what we're going to take is these parts here. Okay, so that's going to be where M is an element of all the values from -infinity up to -14, including it because it's greater than or equal to, union with -2 to +infinity. Right, let's have a look at what that means. Okay, so I'm just going to graph my two functions. This is y equals mx plus 5, and this is y equals x squared take 8x plus 14. Okay, let's just change the properties of that. So we want it to go, let's go to -15. All right, so what I'm going to do is just enlarge this. So we found out that it will have one solution when either m is -14 or -2. Let's see whether that happens. So I'm going to start popping this down. So negative, there's -2. Oh, I can't get this to sit perfectly. Come on. I know what to do. Come on. Need a steady hand. There we go. Okay, there's our one intersection. Okay, so -2 that was. Let's go to -14. Okay, and although we can't see it, it happens somewhere up there. There it is. Right, it looks like a massive intersection, believe me, but that like swings in, it's really close, and somewhere along here is going to be the actual intersection. Okay, and so what we were looking for then for the second solution was when it would be, there would be at least one intersection. So I said less than -14 will produce at least one. So that's going to cut twice. Let's have a look at this one. This one will be much more obvious. So -2, we're about to get one solution, and then obviously all the values above -2, we're going to get two solutions every time. Okay, so back to the examples. Oh, no, that's it. Okay, so again, use this approach for anything that's got parameters in it. Watch your negatives, watch your algebra here, get to the quadratic inequality, must graph that inequality. So try that out on these questions now, and good luck with it. It's difficult, and take your time on these questions.